Architectural Builder's Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
So I was on your website and I was looking at the Monarch RDS 2.
Yes, sir.
Yeah. And so we have, when I work at universities, we have a number of these, and ours might be bad, which is why I'm kind of trying to find one. But I was wondering, do you know much about the technical side of things on this particular unit?
Well, I mean, I do more than most people in the population.
That's good.
You know, I'm always learning every day.
Okay, no, that's good because, I mean, I'm a maintenance repairman, but to be honest, this is the first time I've ever worked on one. And I guess I'm trying to determine for sure if ours is bad or not.
So what's the first thing to do about that?
To figure out if it's bad?
Yeah.
Like the first question I can ask you, or do you have the answer?
No, I'm asking you. What is step one of troubleshooting a circuit?
Probably seeing if there's power there to start.
Wow, perfect. So do you have your multimeter, and have you tested incoming and outgoing voltage?
Yeah, so there's 120 volts coming into that transformer, and then the transformer's outputting 24 volts into the control board. And then the control board, it has, like in our particular circumstance, it has one output that goes down to a door solenoid, you know, like a crash bar solenoid.
Yeah.
And that solenoid's not opening. And there's actually a light on the control board too, and that light is not lighting up either. So we're not getting any voltage down to the solenoid, and actually, I'm sorry, there is like 4 volt DC going down to it. And
so the output on the RDS-2 is 24 VDC.
Right, okay.
Where did you measure for VDC?
I've measured it 2 places, 1 at the solenoid and 2 at the actual control board on those outputs. Like the number 1 and 2.
Yeah, I see.
But I was a little confused because in the manual it talks about how it fires. It almost acts like it puts out 24 and then it goes down to a 5 volt. So I was a little confused by that.
So
our solenoid's a 26 volt solenoid.
Sure. So the RDS, what it actually does is that solenoid requires a huge inrush of voltage, but amps. So you're going to get an inrush for about a second of 24 VDC, and just to be mindful, it's 4 amps. After a second, you should be getting 5 volts DC at 1 amp.
Okay, so
far so good.
Yeah, we're at least on the meter. We're never seeing the 24 volt. So we're seeing the 5 volt, but not the 24 volt inrush. We actually have another door, like it's a double door, kind of like a breezeway. And so they have the exact same unit. And that particular door, like, it would have on my meter at least, it shows 36 volts DC. And then right when you hook the solenoid up to it, it drops down to 5 volts DC. Yeah, we never on the meter are ever seeing a 24 volt inrush.
On the first power supply.
Correct.
Yeah, so that would absolutely prevent that exit device from working. If you're not getting the inrush, it's not going to work. Obviously, the way to test that would be to run a couple of wires from the second power supply to the first exit device.
Yeah, that's a very good idea. It's because it's only like 15 feet away, so that wouldn't be too bad.
Don't give me credit. I'm just a dumb guy from Chicago. I know hot dogs.
Yeah, no, you're doing good. I can do that. Go ahead.
I was going to throw it out there. The next thing that we would want to do is check the ohm value on the solenoid. That'll tell us if there's a short. But there's no reason to even find out what solenoid you have to then find out what the ohm value, the ohm range would be for it, because you're just not getting the voltage, and what you're not getting is the amperage, I would imagine. But that could, yeah. So there's no way to tell that power supply to not give you the inrush. So I would test second power supply to first exit, and then go from there. And obviously, you're testing it under load. You know, you clearly you are, because you tested it at the solenoid. You could only do that. Well, I'm assuming you did it under load. You're going to want to put your voltmeter on it, your multimeter on it, then load and watch the value. You know, hit your card reader, whatever, however you're activating it.
Yeah, and that's very good advice. And so the one thing I had a question on is 7 and 8 actually what's telling it, like, hey, fire on the control board?
7 and 8?
Yeah.
7 and 8 is that's your dry contact switch, which initiates the electric latch retraction operation.
Okay. And so there's no, when you say dry contact, is that because is the button the dry contact?
Well, dry contact just means that there's no voltage present at those terminals. So 7 and 8 is, I'm seriously not a low voltage expert. I do know more than most people just because I sell the hardware. But what they're saying at 7 and 8 is that it's just your switch. I mean, what's activating the circuit? How are you firing the electric latch? Is there a card reader?
No, it's like a building automation system that's on a schedule.
Okay.
So
so your access control. So your access control is going to 7 and 8, isn't it?
Yeah, as far as I'm aware.
Yeah. Yeah, so you're good. I mean, that's how it should be. And the fact that it's dry voltage just means you couldn't power something off of it. Like if you had a keypad on the outside, and the keypad needs a small amount of voltage to work, right? If it was a wet contact, you could power that keypad from the wet contact, but they're literally saying this is a dry contact, meaning fancy way of saying there's no voltage present here. All you're doing is light switch, open or closed.
Okay. So, and I jumped that just to make sure, like the circuit was complete. And
yes, sir.
I would hope,
done.
And nothing happened. Like I said, there's a little light on the board. It will not light up. So, where the other board has a light and it's lit. So,
yeah.
All right. So, do you guys just sell that whole kit, or can you get like different pieces from you?
Well, for the RDS, it's literally only the entire power supply. You wouldn't be getting any components from it. It would be the whole shebang.
Okay. Yeah, you can't just get like a board, basically. You're getting
no.
Okay.
What I would do is replace the board only, keep the enclosure and all the other parts, so that should you need it in the future, you'd have something.
Okay. Well, it sounds like better start with your advice there. Take a wire, run it to the other one, and check that first.
Yeah, be super mindful though. Even though it's only 12 volts, there's 4 amps coming through there. So it's I couldn't really put that into understanding how dangerous it is, but just be super mindful that you've got 4 amps. It's not a third of it's not 1/3 of an amp. It's not 200 milliamps. It's not a doorbell button. It's got the kick of a donkey in it, so
yeah,
be super mindful of it.
No, I'm actually,
don't cross wires. Don't cross the streams.
Yeah, no, I was appreciative you said that, because to be honest, I hadn't really thought about that. But until I was like looking at it, I'm like, yeah, 4 amps, and DC volts, and yeah, probably should be careful. So, but
yeah, it's voltage is anyway, it's a lot of people.
The amperage hurts
that
you.
Water and pipe. I mean, you can literally have 1,000,000 volts, but if you have no punch, you could have potential push. The voltage is the push, but if you're not pushing a lot, then there's just not a lot that's happening. And it's really all quite elegant, the study of electricity. It's when you know how a transformer works and then you plop your phone down onto one of those MagSafe chargers. It's like, this is literally Edison technology, what they're doing here. It is literally from the 19th century. It's so perfect. So, you run current through a wound wire, and magnetism is the byproduct, and that's how that's how transformers work.
Pretty wild
to
me.
Yeah. So my name is Richard. By all means, call me back if there's anything else. I'll chase down the answer if I can't answer it, but do that test first, and let's go from there.
Cool. Thank you so much.
I'm glad you called. Bye-bye.
All right. Bye.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. What ended up happening was the client did indeed, they had two doors, same 18, I don't recall it, I think it was an 18V, same RDS-2 power supply, same solenoid, and that part number of that solenoid, I will tell you what that is. It's discontinued, but we still have access to the original equipment manufacturer on it, just for RDS-2. That solenoid, and we can still buy them without the spring. I'm looking at a screen here. Yeah, definitely an 18, no, a 17 is what it was. A 17, because it's a narrow style. That solenoid part number is 650092, and we can supply the solenoid, but we don't have the spring or the bracket at the far end, so you have to reuse all of that. The bottom line is what the client's got is really old, and what ended up happening is they had one opening that's working. They took, so opening 1 doesn't work, opening 2 does work. They took the power supply from opening 1 and powered the solenoid at opening 2, and it worked. So they therefore knew that it wasn't the power supply, that it's the solenoid in opening 1. So what the client's done is, and the test would have been finding out what the ohm value is for that and then testing that under load. I don't actually know on the solenoid. I'm looking at the one picture that I have. I don't know if you can actually get a multimeter to that to measure ohms without... You may not be able to, is the bottom line. Oh, no, you would be able to. You've got the wire leads. So, yeah, you would be able to check that for sure. You'd have to get on the wire leads to know how much resistance is occurring in the coil. And that would, if we could get the ohm value, which I'm not sure I could get, actually, because of its age, and then you measure that, and then you'll know if it's bad. If it's out of range, then it's bad. You don't need to power supply 2 to solenoid 1, to test it. The client did that, found out that it didn't work, and what they ended up doing was buying 2 power supplies, 2 solenoids, because when they're gone, most likely. So that's what happened on this client's field troubleshooting. Any questions on this or any other Monarch, now Falcon product, please feel free to reach out to us. Thank you.
Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.